Hi students, it's Mrs. Allen, and today's topic is 4.7 inverse trig integration. You can see that we want to integrate functions whose antiderivatives involve inverse trig functions, and so let u be a differentiable function of x, then let a be greater than 0, and we have our three integral formulas given for the arcsine, arctan, and arcsecant. Now, if you recall, when we took the derivative, we ended up with something like 1 over the square root of 1 squared minus u squared, and so on, or for the arcsine. But in this case, when we're integrating, we have a constant. And sometimes we can factor that constant out and get the same thing, but I'll show you how to do that at some later point. So we're just going to use the formulas right now. So for 1, 2, and 3, I had you do them, and this is what they should be, so you can check your work. And I would first start out by saying a squared is 4, so a is going to be equal to 2. And then u is equal to x, du is equal to dx. And I could do a substitution here. I could put a du in here, this one. Okay, and we get arcsine of x over 2 and plus c. Okay, and then for number 2, where we have, it looks like the arctan, right? So with that, we have this answer down here where we have a u substitution. U is equal to 3x, du is equal to 3dx, and du over 3 is equal to dx. So what we're going to do is we're going to factor out a 1/3 and put that out front to get our form for the arctan here. And so then after that point, then we just plug and chug. So we have our 1 over a arctan u over a plus c, and we stuck our 4/3 out front and then plugged in a and u, and we're done. Okay. Now these are indefinite integrals. Okay, we'll talk more about the definite integrals in the next class. So then in this last one, we have u is equal to 2x, where a is equal to 3, u is equal to 2x, and du is equal to 2dx, du over 2, then we have a factor of 1/2 that's going out front. But remember with this one, what makes it a little weird is you have this x here in the denominator, so you have to substitute u over 2 for that one, which cancels the 1/2s out front. You see I've canceled in red. Okay, and then we get the arcsine form that you see here, and we just 1 over a, we plug in our a's and our u's into the formula, boom, we're done. Okay. All right, so then the next problems that we have are problems that we really get started on to, and I wanted to go on and send you a little video for that, recap what we had done, and then get this done. So in this problem, you can look and say, you probably get the feeling that it's some kind of an arcsecant because the variable is first and then the -1 part minus a squared. So with this, I'm going to say u is equal to e to the x, and then du is then going to be e to the x dx. Now, it's going to seem a little awkward at first. Du over e to the x is equal to dx. I'm going to do a substitution first, but because I think it's the arcsecant, I'm going to need an x or a function down below. So let's see how this works out. So we have du is equal to, du over e to the x is equal to dx. So I did the substitution in this step, and then you can see what I have. I simplified a little bit to get to this part, slid the e to the x down there, and part of what you're thinking right now is, wait a minute, we have x's and u's. You're absolutely right, so we can't have that. So now what we have to do is we have to say, well, we know what we have here. Our u then is e to the x, right? So now what I can do, I've already got everything, my du in place, and I can go back now and I can say, well, that's u then. U is equal to e to the x. And then we have this u squared minus 1 here. So now we have our form set, right? We've got it all set. So this is our a is equal to 1. We have that. So now we can finish this off and we can say that, well, this is then the arcsecant, right? So it's 1 over a, arcsecant. And then there is this absolute value thing that we put in here. It's absolute value of u over a, and then we have a plus c, right? So I'm going to move this up here. So we end up with, this is going to be 1 over 1, so it's just 1. So it's going to be arcsecant of the absolute value of e to the x, which you don't need the absolute value, over 1. So it's going to be e to the x over 1 here. So it's just going to be e to the x, and then just plus c. And there's our answer here. Because the u is equal to e to the x, and the a is equal to 1, makes it a little simpler. Okay, so there's that one. Now, if I come over to this one, what I'm going to do first is I'm going to look at this and think, if I make it x over the square root of 4 minus x squared, and then 2 times the integral of 1 over 4 minus x squared, it looks like I have a simple u sub for the first one, where I'm going to say u is equal to 4 minus x squared, then du is equal to negative 2x dx. So I'm just going to say du over negative 2 is equal to x dx, and that will get me through the first integral. I'm missing the dx. I'm going to throw it in up here, if that's all right. Okay, so I have that one. And then if I look at this next one, it looks like I could use another u. Maybe I should use a v. I hope you pardon. Let's make this a u1, and then I'll make a u2. Good man. I'm going to say that that's going to be equal to x, and a is 2. A is equal to 2. So I'm just going to do, and the du is equal to, I'll say du2 is equal to dx. So it's a separate problem here, a little. And so then I get negative 1/2. I'm going to pass the negative 1/2 out front. And then I have the integral of u to the negative 1/2 dx. Okay, everything's eaten up by the x. dx becomes a du. Oh, du. Okay, so there I have that. And then I have plus, it's going to become a, oh, it is a plus. It's not a minus here. That's a plus. So plus 2. And that's going to be the integral of, I'm going to keep it as a u squared still. But I got to be careful. Maybe I should make that a v. Let me make it a v just because it's a different one. So then I'm going to have it as a squared. So I'm going to have a dv is going to substitute there. And then a square root of then a squared, because a is 2, a squared minus u squared, v squared, right? A squared minus b squared. So clearly that's going to be your arc sine there, right? More like the 1 minus. All right, so then we have negative 1/2 times this integral. When we take the antiderivative, we're going to get 2u to the 1/2. And then we have plus 2, and this is going to be the arc sine. So we have arc sine of v over a, and then plus c. So when I continue this, then I can back substitute. Remember, this is a positive square root. The 2's cancel here. So I have negative is going to be the square root of u. We can put the u back in. U is 4 minus x squared, right? And then we have plus 2 arc sine. And then v at this case is equal to x. So we just have x, and a is 2 over 2, and then plus c. So we have our whole answer here. Just splitting up an integral. Sometimes you have to integrate 2 separate parts differently, as we did, u sub and n. Now, for the next one, we've got this binomial squared in the denominator. So when I first look at this, it looks just like an arctan. You're probably thinking that same thing, right? So I have that x plus 1 squared in the denominator, and I think, so I might want to make that an x plus 1 in the numerator as well. So you see where I added 3? So if you look at that, where I add, I didn't mean add 3 at that step. I was thinking of taking this and changing this so that this was x plus 1, and then I would subtract 3, because then that would be the same value, right? Same value. And so then I can force a split here, okay? So let's see how this works. So if I take this, it'll be the integral of x plus 1 over that whole denominator, x plus 1 squared plus 4 dx. And then I could make that just a minus 3 times the integral of 1 over x plus 1 squared plus 4 dx. Okay, so now in the first one, now I'm looking at it and thinking, that's a u sub, right? So if you think about this, u is equal to then, take the whole denominator for this, right? So u is equal to x plus 1 squared plus 4. So I'm going to take the whole thing, and then I'm going to say du is then equal to 2u, or 2, sorry, x plus 1, like that. So that's what the denominator It's the denominator derivative, right? So then I have du over 2 is equal to x plus 1 dx, which I have in the numerator, right? So let's stick with this one while we're working on it and just set it up. So this would be 1/2 times the integral of 1 over u du. 1 over u du. Okay, then we'll work on this other one. So we know the other one already has the arc tangent form. So if I look at the denominator and I say, well, if I do this and I say, well, let's use a v. V is equal to x plus 1, and a is equal to 2, and dv is equal to dx. So then I can just go ahead and say, well, this is then minus 3 times the integral of dv over v squared plus a squared. So I'm all set up there as well. So then I can do the first integral. I would say that this is 1/2 times ln of the absolute value of u minus 3 times 1 over a. So I'm going to write out the formula first. 1 over a, and we know it's the arctan of v over a, and then plus the arbitrary constant, okay? So then I'm going to bring this up here, and again, got to be careful with your u's, because remember what your u is now. It's that whole up here, it's that whole enchilada. And it's always going to be positive, so we don't really need absolute value with that either. So we would have that the integral, let's put a little equal sign, it starts getting kind of long. Put this here, and so we have the integral then is equal to 1/2 ln of x plus 1, the quantity squared, plus 4, minus 3 over 2, because a is 2 there, 3 over 2 arctan. I'm going to run out of room here. 3 over 2, because it's going to be 3 times 1 over 2, and then we have arctan of x plus 1 over 2, and then plus the arbitrary constant c. Okay? All right, I'm going to straighten this out, and there you go. There you have it. There it is. Okay, so in this one, again, you often have a couple different ways, strategies that you're going to need to use to integrate, where you have one integral, but you've got to split it apart and handle the integration in 2 different ways. Okay? So I think I have that all said there, and let's move down. Now, for the next one, we're going to come up with the square for this one. This one isn't too bad. So what I'm going to do is I'm going to look at how to complete the square with this. Remember, you add the b value divided by 2 and square it. So this is then going to be -2 squared. -2 squared is going to be added on. What we're going to do, we're going to take that denominator. We have to keep it equivalent, right? So I'm going to add -2 squared, and I'm going to subtract it, right? So I have this x squared minus 4x minus 4, because automatically you're thinking this is an arctan. And then this is going to be plus 4. So it's going to be plus, I'm going to take that as my trinomial, my quadratic trinomial, and then I'm going to have 7 minus 4, which turns out to be 3. All right, 7 minus 4, 3. All right, so then I'm going to factor that this is x minus 2, the quantity squared, plus 3, and that's going to be the square root of 3 squared. So you can see what your a value is now, okay? So in this, u is x minus 2, and a is equal to 3. And du is equal to dx. So we're ready to go. Here, so we have du. So this is then going to be x minus 2, the quantity squared, plus the square root of 3 squared. You could just leave it 3, though. Okay, so this is easily handled then. 1 over a arctan of x over a plus c. So we plug in our a, 1 over square root of 3. Arctan, and that's x over the square root of 3. I just leave the denominator as a square root. I don't ever worry in this case. Don't worry about rationalizing the denominator. It just gets uglier. Okay, and, oh, I'm sorry, x minus 2. Oh, I should have had u in that previous one, right? There should be a u here. And I fell into that trap here. That should be then x minus 2 here, and not not just you, okay? And there's that one. Okay, so I think that covers them all, and I will see you tomorrow in class, review these videos, and attempt the homework. I will see you tomorrow. Bye.